All textures in worlds are automatically compressed to 128 by 128 pixels. This means that no matter how big you blow up an image, it's always going to look compressed. So then how does ground zero have this detailed of an infinite background? Well, the answer is CompImg, and I'm going to explain how you can make your own high-resolution textures in this video, CompImg Part 2. So if we inspect it in Shaper, we see it's actually made up of multiple recs, and each of these is a high-res texture. So if we go to this one, and we look at what the texture is, we see that it's sky 13, and then 2H star, 2V star, and this is the critical part of how this move file is used to create such a high resolution texture. So let's open up this texture in CMP view and we'll see how it's made up of. And you can open these sort of .move files in CMP view and you can see it's 4 frames that covers 4 sections of this part of the background. And each of these sections is 128 by 128. But when you tile them all together, it creates something that's twice as big as, you know, the one texture. So let's make our own. Here's a photograph I took. It's very high res. You can see that it is almost 720p. So if I imported this into Worlds right now, it would look like this. And it doesn't look good, so we're going to do the high-res technique to it to make it be able to be actually seen for what it is. Okay, so the first thing to do is split up the image into like squares, so we're going to do that. Here's how it would look like. And so I decided that the best way to divide this up would be 4 by 4. The easiest way to do that would be to open up Wolfram Alpha, and I'll show you what I did exactly. So the height of the image is 1068, so I'm going to do prime divisors of 1068. And you can see there's some good. I try to pick something in the lower side of things, so I chose 4, and so we do 1068 over 4. And so it's 267, so we're going to write down 267. And I'll spare showing you the division of doing the height, but the end result is getting 267 by 178 for each of these rectangles. Now, I made this image as a demonstration to see how it's all split up, but you do not need to do all this. All you need to know is the height and the width number that we just calculated, and then we're going to do some math to it to make this a lot easier. Theoretically, what you could do is crop out every single one of these little sections and then tile them all yourself in Worlds, but there's a much easier way of doing that, and that's what I'm going to show you how to do it. So here's all the numbers that we're going to need. The total width of the image, W. The total height of the image, H. The width of each subsection of the image, X. And the height of each subsection, Y. So this might make more sense if you have like a programming background, but I'm going to explain it the best that I can. It's best to think of the sections of your image like a coordinate system where the top left is 0, 0, and we're going to call this I, comma, J for all of our calculations. So we have 16 unique squares, so we're going to need 16 lines in a text document. And all of this right now is just reminder, helpfulness. So for each line, we're going to format it exactly like this sort of math here. So j times x for this top left corner, j0 is going to be 0. I times y again, that's going to be 0. Then it's going to be width minus x times j plus 1. So width is the total width in the image, 1068 minus x, 267 times 0 plus 1. And we're just gonna crunch that real quick. I'm just gonna use the computer. And this is 801. And then we're gonna do it again for this next one. So this is gonna be the total height of the image is 712 minus y 178 times 0 plus 1. and that's going to give us 5, 3, 4. And we're going to do this for every single one of these in the 4x4 grid here. And I'll do one more example here. So for this one, this will be for 1, 1. So again, it's 1 times 267, 267. And then it will be 1 times y, 178. Be w, 1068 minus x, 267 times j, 1 plus 1. This ends up being 534. We've seen that number a few times now. And then again, it's 712 minus 178, 1 plus 1. And this ends up being 356. And then we're going to have eventually all 16 lines. And we're going to delete all this stuff at the top. That was just a reminder. And we're going to save this as, it could just be any sort of text file. I usually name it as whatever .crop. I've seen .til, but you just need to save it. So I'm going to save it in the same directory as I have CompImg, and I'm going to call it tutorial.crop. Now we need to make a second text file, another .list file like we have done for holograms. But this time it's just going to be the same file for every line in the crop file, so it's going to be 16. So we're going to put high-res original.bitmap, which is the name of the original image that I have, and then we're going to just paste it 16 times. And then we're just going to save this as something.list, so I'm just going to save this one as tutorial.list. And then we're going to go to our command line, and we're going to get ready to use CompImg like we have before. So CompImg, and we're going to put in the commands that we similarly did for the hologram. So we want .w.emove -M tutorial. And so here are the things that are different. So sometimes you want T 0, 0 if you want transparency. We don't, so we're going to leave that one out. We want CL, and that's our crop list. So we want -CL, and then we're going to do tutorial.crop there. And then we're going to do plus tutorial.list. And then we're going to run. And it's going to write our .move file. And hopefully we wrote the crop file right, so there's no wrong sizing issues. And then we're going to head back to World Shaper, and here's our bad one. We're going to change the texture to J, and we called it tutorial.move. And see, that's only the top left half. So remember, we made it 4x4, so we're going to change the file name here. So we're going to do 4H for horizontal star, and then 4V for vertical star. And there it is, and it looks really good for a world's texture. The colors are a little reduced, but it is photo quality, and you can make it as beautiful as this background is in Ground Zero. So yeah, there's a lot of steps to this and a lot of math to do it. I did write a small little Java program to semi-automate the process. There are a few kinks I wanted to work with the world's version of Java, so I'm still kind of working on it. But it will do all of the crop file and list stuff automatically, and then it'll run CompImg automatically, so you don't have to do the math for it. So when this is available, I'll pin a comment on this video with like a download link or something like that, but you can do it completely by yourself. I think SGeo has a GitHub out there somewhere with a Rust file that does something very similar, but I think his actually crops the image and like saves temporary image files. I think using the crop file is like a really clean way of doing this with just a little bit of math. And that's going to be it for this one. Another big use for these .mov files that you can create with CompImg. A word of warning, so number one, if you use an image that's way too big with way too many subsections, you're gonna crash. I would say err on the side of images like maybe 2000 by 2000 and lower. I think I tried like a 4K image and that crashed it. I never tested the limits of what's possible with this, but yeah, too big of an image will crash, and it'll also take longer to load because it's basically loading like a tile grid of textures. So expect these things to load maybe the last in your world, and use them sparingly because it will increase load times. Thanks for watching.